DC circuits part 3. In this section, we will be covering about what are potential different dividers and how do we use potential dividers to speed up the voltage of the original source. Okay, so this is the learning outcome. Okay, so what is exactly a potential divider? Just by the name, it is to divide the potential difference. So a potential divider usually consists of a line of resistors connected in series. So as you can see over here, I have two resistors in series, or I can have a variable resistor and another resistor in series, or I can just have a sliding contact. Okay, so this entire bar R is my resistance. And it is often used to provide a fraction of the voltage of the source to another part of the circuit. So I can actually vary the amount of voltage that comes out to another circuit. Okay, I might not need the entire voltage over here. In this case, where I put two fixed resistors, I can't really vary the amount of V out. But if I put a variable resistor, or if I were to use a sliding contact over here, I can actually change the amount of V out over here by adjusting either the resistance of the variable resistor or by sliding up and down towards A or B. Okay, I can vary my V out, which can then be used to power up another circuit depending on the voltage requirement of the other circuits. Okay, we'll zoom into examples and the formula used to calculate the V out for each case. Okay, so these are the steps to derive the formulas, but you do not need to know the steps. You only need to know the formulas, but I'm still going to go through how you can derive the formulas. So you have a series circuit where you have two resistors connected in series. You know that in a series circuit, the current will be the same. So the current flowing through this circuit will be I equals to Vs over R1 plus R2. Over here, Vs over R1 plus R2. Okay, so this is the current flowing through it. And if I wanted to find V1, I will use the current over here times R1. So I want to find V1, I take I times R1, and I will sub in this formula, which is Vs over R1 plus R2. I will get V1 equals to this formula over here. Okay, but in simple terms, we can also think of it as a ratio. Okay, so V1 and V2 will add up to become Vs. Okay, so I know that I need some energy to pass through R1. And the amount of energy that I need to pass through R1 for each charge will be V1. So if I want to find V1, I will just have to take the ratio of R1 against the total ratio, or against the total resistance, R1 plus R2, and then multiply by Vs. Okay, because it's a ratio thing. Okay, and then if I want to get V2, okay, I just take the resistance of R2 over the total resistance times Vs. Again, okay, so these are the two formulas. This is the main formula for potential divider. Okay, so next, let's come to other question. What will happen to V2 when R1 is increased? Okay, so if we increase R1, you might see that if I have a higher resistance, I will need more energy to go through it. So if I increase my R1, my energy level over here will have to increase in order to go through R1. So if V1 were to increase, V2 will decrease because V1 and V2 will add up to be Vs. Okay, the voltage is shared across R1 and R2. So if R1, the voltage increase, R2, the voltage should decrease. Okay, but what happens next? Okay, if I have R2 is increased, I'm going to use the blue arrows instead. The second part, if R2 were to increase, then my V2 will increase because I need more energy to flow through this R2, and my R1 will decrease. Okay. Okay, then let's take a look. Which of the two following circuits will produce a larger V out? Okay, so we go back to apply the same concept. If I have a larger resistance, I will need more energy. So my V out is at the bottom. Okay, it's from A to C over here. V out is connected across A to C. Okay, so you can see that in this circuit one, A to C has a larger resistance. R2 is greater than R1. So if I have a larger resistance, I will need more energy to go through it, so I'll have a larger V out. As compared to circuit 2, my R2 is so much smaller than my R1. So my R1 will be the one that takes up more energy, will require more voltage. So more of the EMF will go to R1 rather than to R2. So my V out should be smaller. So which circuit will give you a larger V out? The answer is circuit 1. Okay, because it has a larger resistance across the V out. Okay, so let's go into questions with numerical values. You may pause the video at this point to think of the answers. Okay, I'm going to go through the answers. A potential divider is constructed with resistors each of 20 ohms connected. What is the output voltage across R2? This is very straightforward because the two resistors are of equal values. So the voltage will be split equally, 6 volts over here. But if we were to use the formula for potential divider, okay, so I want to get V out, so I need to use resistance 2, which is 20 over the total, which is 40, 20 over 40 times the original value 12. Okay, so I get 20 over 40 times 12, I also get 6 volts. Okay, next, what modification can be made to the circuit if we want to increase the value of V out? Okay, if we want to increase V out over here, okay, you know that we need to increase the resistance over here. Or I can also choose to decrease the resistance over R1. I can choose either to increase the resistance of R2, so that I need more energy over here, I need more V out over here, or I can choose to decrease the resistance of R1. If I were to decrease the resistance of R1, then the voltage across R1 will drop, and because the voltage is shared to be 12 volts, the voltage V out over here will increase. Okay, let's move on to the next question. You may again pause the video to think of the answers. Okay, I'm going to go through now. So there is a 9-volt battery is connected in series with a variable resistor and a 50 ohm resistor, and the V out is across the R2. Okay, the question is asking this resistor R1, variable resistor, can vary from between 0 to 100 ohms. What is the maximum and minimum output voltage that can come out from R2 over here? So you should know that if I want my maximum output voltage, okay, I want all my V out to be here, simply means that I were to cancel this resistor. This resistor can be at 0 ohms, no resistance at all. So my voltage don't need to share with this R1. All my voltage will go over to R2. So my maximum voltage is when R1 is 0, no resistor at all, and all the 9 volts goes to R2. So V out will be 9 volts. That's my maximum. Okay, then let's come back to here again. If I were to get my minimum output voltage, if I want minimum over here, means all the voltage must go over to the top. So my top one, my resistance should be a maximum, which is 100 ohms over here. Okay, so I have 100 ohms over here. I only have a 50 ohms over here. So if I want to get the V out here, will be 50 out of 100 plus 50, 150 times 9. Okay, so you get the formula as follows. 50 over 150 times 9 volts, which is 3 volts. That will be the minimum output voltage. Okay, next, let's take a look at another question. Okay, so this is a volume control knob of an electric guitar. The full range is 270 degrees, and you have a slider which is attached to the V out. Okay, and the slider is at 90 degrees. Okay, you can imagine this entire slider as a straight line if you were to straighten it. But now, because it's a curve, that's why they give you in the ratio of angles. Okay, so you may assume that the resistance of the potentiometer increase or decrease linearly. So this slider has a very constant resistance throughout its entire angle or throughout its entire length. Okay, so V out is over here, V out. So this is 90 degrees. My slider is at 90 degrees. So 90 degrees is to my V out. Okay, so if you were to take the ratio again, okay, my original voltage over here is 15 volts. Okay, so if I would take ratio, I'll have 90 over the total, which is 270 degrees. Okay, this entire length is 270 degrees. So the answer is 90 divided by 270 times the original voltage, which is 15 volts. So you get 5 volts. This section will only hold 5 volts, and this other section will hold 10 volts from 90 to 270 degrees. Okay, it's simply by a ratio method again. Okay, let's move on. Next question. There are two resistors connected in series, 5 ohms and 15 ohms. What is the current flowing in the circuit? So I know I need to use I equals to V over R. So I need to find the current flowing through in the circuit. I will use my current. I will use my voltage, 2 volts divided by my total resistance. So it's 20. So 2 divided by 20, I get 0.1 ampere. So that is my current flowing through the 5 ohm. That's my current flowing through the 15 ohms. At any point is 0.1 ampere. Okay, and then the question asks, I also need to find the potential difference across each resistor. So the current is 0.1. So I want to find the voltage across 5 ohms. V equals to IR. So it's 0.1 times 5 and 0.1 times 15. Okay, so I get 0.5 volts and 1.5 volts. So they ask you, is this a potential divider circuit? Yes, because I am splitting my 2 volts up into 0.5 volts over here. Okay, let me jot down 0.5 volts over here. I'm splitting it. I consist of 2 resistors connected in series, so I split up my voltage into 0.5 volts and 1.5 volts. So this is a potential divider circuit. Okay, next question. An additional resistor of 20 ohms is added in parallel to the resistor. So now over here, let me erase first. I have another resistor which is connected in parallel across here, which is 20 ohms. Okay, I have let me draw properly first. Okay, I add another resistor, 20 ohms, in parallel across all the resistors. What is the total resistance now? So now I have 20 ohms here, 20 ohms here. I want to find the total resistance is 1 over 20 plus 1 over 20, which is equivalent to 2 over 20. Then I need to flip it. So after I flip it, I'll get 10 ohms. So these two combined will become 10 ohms. So the current drawn now is, what is the current drawn? So the current I equals to V over R. So it will be 2 over 20, 2 over 10, sorry, 2 over 10. My total resistance is 10, it will be 0.2 ampere. And then is the effective resistance larger or smaller? It will become larger. Okay, the effective resistance, oh, I'm so sorry. The effective resistance is smaller, not larger. Okay, because I add a resistor in parallel, so my total resistance would have dropped. Okay, so the effective resistance in question 1 is larger. Okay, in question 2, it will be smaller because I add another resistor in parallel. Okay, next. So a summary, a potential divider is a voltage divider. It makes use of the voltage drop across resistors to split up the voltage of the original source. A potentiometer can provide a continuous range of voltage for V1 and V2. Because a potentiometer, you can vary the resistance across and you get different sets of V1 and V2. For a potential divider and a potentiometer, V1 and V2 can be calculated by the following ratio. So if I want V1, I take the resistance R1 over the entire resistance times the original voltage, Vs. For V2, I'll just take the resistance of R2 over the entire circuit resistance times Vs. Okay, that's it for this section.